Now in this video we're going to do a quick review of current going through a resistor based on voltage across it. If you measure with a meter, a multimeter or other current meter, the meter does not limit current at all or drop voltage. So probably a spec, but not really noticeable. So in any case, whatever the power supply voltage is, even if you're measuring it with the meter, red probe to the resistor in this case, black probe to the ground symbol, you will get the accurate amount of current that is flowing through the resistor without the meter. But in any case, 1 kilo ohm resistor, 1000 ohms, makes the math really easy. For each volt across it, you're going to have 1 milliamp of current going through that. So you can do the math if you want to. 9 volts divided by 1000 ohms is a 0.009 amps, or 9 thousandths of an amp right there, or 9 milliamps if you want to look at it that way. So there's the Ohm's law formula. Current, they use I for some reason, equals voltage divided by resistance. So current in amps, voltage in volts, resistance in ohms, right there. Now, you also want to calculate the power. It's important that you don't overheat the resistor. So you take the current in amps times the voltage in volts, and you get the wattage. So most resistors are rated for 0.25 watts, the vast majority of them. And so usually you gotta like special order them for a different wattage. But in any case, you can see this is well below, especially the 0.25, but you still want to keep it below an eighth of a watt. So that's the absolute maximum. This is the recommended wattage that you want to stay below. So 0.125 watts. You want to keep them about halfway or less than their maximum wattage. So in any case, you generally won't see pictorials like that. I'm going to be adding more to my website, but usually you see the schematic diagram more. So it's really important that you learn that kind of quick. So this is a schematic symbol for the resistor. This one, this oval with the number in it, that indicates you're taking a current measurement. Or you could just say that's how much current's flowing through that point if you want to. But that indicates a current measurement. And so 10 volts across a 1000 ohm resistor. This is a ground symbol right there. And ground symbol, that's the negative side of a power supply. When you just got a plus and a minus, positive and a negative, that is almost always the negative side of the power supply. You just consider that 0 volts, and then the positive side of the supply, you consider that to be whatever the voltage is set to right there. So that's 10 volts across a resistor there. We got 10 volts one side, 0 on the other. That's a 10 volt difference. So if it's 1000 ohms, 10 volt difference, you got 10 milliamps. Pretty straightforward. And there I did the math right there, 0.01 amps. So we'll kind of rush through this. When it comes to the wattage, again, you take that number you just calculated times the voltage. So amps times voltage. And you got 0.1 watts right there for 100 milliwatts. So plenty cool right there. You're still a bit below the 0.125 watts. Now, we're going to come to another example. The 220 ohm resistor with 5 volts across it. So this is a good value to learn because there's a lot of 5 volt circuits out there. A lot of times there's a 220 ohm resistor because that's a common value, and it's a decent value for protecting an LED. LED should not have more than 20 milliamps of current going through it. The LED takes away some of the voltage from the resistor. Topics covered in other videos, where ultimately you end up with less than 20 milliamps. But the resistor by itself with 5 volts across it, you're going to get about 23 milliamps of current. So I rounded that off. This one's a little less round off. We got the formula here. 5 volts divided by 220 ohms equals 0.0227, and then it keeps repeating, 227 amps. But I just put those dots to indicate it keeps repeating over and over again. We're going to round it off again to 22.7 milliamps. So again, you do the math. The current in amps times the voltage in volts across it. And we got 0.1135. I accidentally put an A there. Should have been a W. But 113.5 milliwatts right there. Still below the wattage rating there. So if we drop the voltage even more with other components, the resistor is going to be even cooler. We're plenty safe using a 220 ohm resistor anywhere in a 5 volt circuit as far as the resistor is concerned. It won't get too hot. So in any case, just mostly a review for those that already knew this, and for those that don't, this is important stuff, so hope you paid attention, or else the rest of electronics is pretty confusing. Learning to limit current with the resistor is an important part. But in any case, check out one of the other videos I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. I have links down in the description. But just watching videos helps a ton. Thanks to everybody that does that. I'll see ya in the next video.